Assalamualaikum and a very good day. So in this video I will show on the chapter 4 sampling distribution. Okay, so the aim of this chapter is to calculate the probability of single means and also two means. So what is the sampling distribution? Okay, let's say we have the population of the women in the age of 20 to 23, okay, in our class. Okay, so that means, let's say we have about 70 students, okay, in the class, but we just take around 30 students, okay, to do a sampling. Okay, so this is called as the sampling distribution. From the population, we just take a sample. Okay, so now in this sampling distribution, okay, we have the single mean and also the two means. Okay, before that I would like to revise what you already learned. Okay, so you have the mu, which is equal to the mean, and you know the notation of the variance. You have the sigma square and also the standard deviation of the sigma. Okay, so from chapter 1 to chapter 3 you already learn on the notation. But in this chapter, you are going to use this symbol. Okay, you have the mu, okay, you have the mean, but you have also the x bar. This one is for the mean of the sample distribution. And you have the variance, but you have the x bar, okay, for a sample. And you have the standard deviation, but you also have the x bar. Okay, this is for the single mean notation. But for the two means notation, you will have the x1 bar minus x2 bar. Okay, so it's goes same for the mean, for the variance, and also the standard deviation. You have the x1 bar minus x2 bar. So make sure you already clear on this notation. Okay, now, so we know that the aim of this chapter is to calculate the probability of the mean and also the average. Okay, so that means we want to calculate the probability. Okay, we already calculate the probability from the chapter 1, chapter 2, and also chapter 2. But for this chapter, we also want to calculate the probability, but the probability of the mean or the average. Okay, so we are going to use the standardized normal distribution. That means we're going to use the Z. Okay, that means we must refer to the to the table 3. Okay, on the normal distribution table. Okay, now, so there are 4 steps, okay, in getting the probability of the single mean. So what does it mean by the single mean? That means we want to calculate the probability of the mean, but single mean for only one mean and two mean for the two means, between the two means. Okay, there are 4 steps. Okay, the first step is we must find the mean of sample. Okay, that means from the question, we are already given the mean of the population. Okay, that means we are given the mean of the population, and also we are given the variance or the standard deviation of the populations. Okay, so we are going to find the mean of the sample. What is the formula of the mean, or what is the notation of the mean of the sample? We have the mu x bar. This one is the mean, is for the mean of the sample. But this mu, okay, this mu is the mean for the population that are given from the question. And we know that from the step 1, the mean of the sample is equal to the mean of the population. And step 2, the formula of getting the standard deviation of the sample. Okay, we have this sigma x bar, that means the standard deviation of the sample, is equal to the sigma, that means the standard deviation of the population, over the square root of the n. N is the number of sample. Okay, step 3. We are going to write the notation of the normal distribution. We have the x bar. What does it mean, x bar? From the chapter 3, we are only use the x, right? But for this chapter, we are going to use the x bar, mean of sample. Okay, x bar approximate to the normal distribution, because we use the normal distribution, mean of the sample, and also variance of the sample. That means in this notation, your mean and also your variance come from the step 1 and step 2. Make sure you didn't use the mean and the variance of the population. You must use the mean and variance of the sample. Okay, for step 4, find the probability of the mean sample. Okay, this one is given from the question. Okay, let's say the question asks what is the probability of the sample is getting greater than 12, let's say. So it's come from your question. Okay, now the probability of the mean sample, let's say greater than R, is equal to probability of Z. Okay, this is because we standardize the normal distribution. So that means we are going to use the Z. Is equal to R, okay, minus the, okay, again, you have the mu, the mean of the sample, is come from the step 1, and also the standard deviation of sample is come from the step 2. Okay, so make sure you substitute the mean and also the standard deviation from the sample mean. Okay, so for the notation of the step 3, okay, because we have the mean and also the variance, that means the result from the step 2 you must square, because step 2 you calculate the standard deviation. In step 3 we are going to write on the variance. Okay. Okay, now we look at the example. Okay, example 2. What is the probability that a sample of 100 automobile insurance claim files will yield an average claim of 4,052.77 or less? Okay, now from this question, we have an average claim. We have the word of average. If the average claim for the population is 4560 with standard deviation of 600. Okay, now from this question, okay, we have the information of the average claim for the population is 4560. That means this is your mean of population. And also the standard deviation of your population is 600. Okay, then you have a probability. What is the probability? A sample of 100 automobile. That means your n is equal to 100. And the question asks you what is the probability. An average claim is 4527.77 or less. Okay, now we look how to solve this example. Okay, now n is equal to 100. Your average, okay, the probability that you want to look for is probability of x bar less or equal to 4527.77, and your mean of population is 4560, and the standard deviation of population is 600. So from step 1, your mean of the sample is equal to the mean of population. That means your mean of the sample is equal to 4560. Okay. For step 2, your standard deviation of sample is equal to the standard deviation of the population divided by the square root of the n. So your standard deviation of the population is 600. So divide by the square root of your n is 100. Then you get 60. So for step 3, we want to write the notation of the sample mean. Okay, so we have x bar, approximate your normal. Okay, this one your mean of the sample. Okay, that you already calculate from the step 1, 4560, and the variance of the sample that you already calculate from step 2. But the step 2 is for the standard deviation. So the variance is 60 square. Okay, so step 4, we want to look from the question the probability when your x bar less or equal to 4527.77. So it's equal to, okay, so we must standardize the normal distribution. Then we have the z. Then you have the x. Okay, this one is for your x bar is 4527.77 minus the mu x bar or the mean of the sample, in which you already calculate from the step 1 is equal to 4560 over the standard deviation of the sample that you already calculate from the step 2 is equal to 60. Then you simplify, you get less than equal to negative 0.54. Okay, this step from the step 4, okay, you already learned from the chapter 2 on the normal distribution. So when you have the less equal to the negative, okay, you must refer to the table. Okay, then is equal to greater equal to 0.54, then is equal to 0.2946. That means you must refer to your chapter 3 on the normal distribution if you still didn't clear on this step. Okay, now we proceed to the next example on the example 3. So the random variable x, okay, represent the number of boxes in a container, has the following probability distribution. That means we have the x, okay, and also we have the probability. Okay, so question A, find the population mean and variance. Okay, this data, okay, is already given. Okay, and this data is the information of the population. So you are given the random variable of x and also the probability of x. So the question asks you to find the population of mean and variance. So you already learned on how to calculate the mean and variance from the random variable in chapter 2. Okay, now the formula of mean, okay, is equal to the summation of the x times with the probability of x. So for this table, okay, we have 4 times 0.2 plus 5 times 0.4 plus 6 times 0.3 and plus 7 times 0.1. Then you get is equal to 5.3. So for the variance is equal to the EX square minus the EX square. Okay, so this is the formula of EX square. That means your X square times with the X, 5 square times with the 0.4, 6 square times 0.3, and 7 square times 0.1. Then you get 28.9. Okay, so you have the value of EX square, 28.9, minus the EX, the mean, square. Then we get is equal to 0.81. So this is how you calculate the mean and also the variance of the population. We proceed on question B. Find the sample mean and variance for random sample of 36 boxes. Okay, now from the question A, we already calculate the population of the mean and also the variance. But for the question B, we must find the sample mean and also the variance. Okay, now how to get the sample mean and also the variance? Okay, from the step 1, we can calculate the sample mean in which your sample mean is equal to your population mean. And for the variance is equal to your standard deviation of the population divided with your square root of your n. So how to get your n? N is a 36. Okay, because we use the random sample of 36 boxes. Okay, so for the mean sample, okay, is equal to your mean of the population. That means is equal to 5.3. And for your the mean variance, okay, is equal to your standard deviation divided with the square root of your n. So we know that your n is equal to 36. Okay, and for your standard deviation of your population is equal to square root of 0.81. Okay, in which from A you already get the value of variance which is equal to 0.81. Okay, so for the standard deviation is the square root, then you have the answer is equal to 0.15. Okay, now we look on the question C. Calculate the probability if the average number of boxes in 36 container will be less than 5.5. Okay, now we must calculate the probability of the average. That means we are going to use the sampling distribution because we know that the sampling distribution is to find the probability of the mean or the average. So the question asks you to find the probability of the average of your n is equal to 36 will be less than 5.5. That means your S bar is less than 5.5. Okay, now so you must calculate the probability, okay, when your mean average, okay, of the box, okay, less than 5.5. So the step 1 you already calculate from your step question number B 5.3. Step 2 you already calculate from your question B 0.15. So for the step 3, okay, we just write the notation. Okay, your mean of the sample is 5.3 from the step 1, and the step 2 is your standard deviation. Okay, this one 0.15. It's supposed to have the square. Okay. Okay, so please do the correction. You must add the square here. So the step 4, okay, standardize the normal distribution. That means you have the x bar minus the mean of the sample. Okay, 5.3 from the step 1. Okay, over the standard deviation from the step 2, 0.15. Then you get z less than 1.33. Okay, so z less than 1.33 is equal to 1 minus the probability of z greater than 1.33. Now z greater than 1.33, now you can look straightforward from the table 3. Okay, standard normal distribution table. Then you get is equal to 0.09176. So 1 minus the probability of z greater than 1.33, then you get 0.9082.